Hello everyone, welcome back. Today we'll cover another topic in Spring Framework series on ClassPath scanning and managed components. So without any further delay, let's start. One of the key features of Spring is its ability to perform ClassPath scanning. This means that it can automatically discover and instantiate components in your application based on their ClassPath location. So what exactly it scans? It will check all the components in the mentioned path and identify if any classes are annotated with annotations to make them managed by Spring IOC container. For example, if we have a class that is annotated with @component annotation and is in the scan path, so its bean instance will be created on the application startup and managed by the Spring IOC automatically. To use ClassPath scanning in Spring, you need to use @component scan annotation. This annotation tells Spring where to look for the components that need to be managed. Let me show you an example. Here we have a sample Spring application with a few components defined. We can use @component scan annotation to tell Spring where to look for these components. In this code snippet, we have a configuration class called appConfig. We have also used @component scan annotation to specify that Spring should scan com.application.main package for the components to manage. Now let's take a look at the components that we want Spring to manage. Here we have a simple print message component. As you can see, we have used @component annotation to indicate that this class is a managed component. Here we have another class that uses print message component. So in this class, we have used @AutoWired annotation to inject an instance of print message. We can then use the component to do some useful stuff in our application. These components are present under com.application.main package or its subpackages. So as per the configuration of component scan, all classes under com.application.main and its subpackages will be scanned for the appropriate annotations to identify the components to be managed by Spring IOC container. Spring uses component scanning to automatically detect the certain annotations such as component, service, repository, etc. and creates the instances of those classes that can be used in your application. By using @component scan annotation, you can specify the base package or packages to search for components. Spring will then search for the classes in those packages that have the specified annotations and create the instance of those classes. The @component scan annotation in Spring provides several options that you can use to customize the component scanning process. We will try to understand them with some examples. Let's say you have the following package structure in your project as given in this image. So in this example, you want to scan com.example.myapp and its subpackages for the components to manage. You can use base packages option to specify the base package to search for the components. Spring will scan com.example.myapp and its subpackages looking for the classes which are annotated with component, service, repository, controller or configuration. Spring will then create instance of those classes that can be used in your application. We can also specify multiple packages also like that. So here you can see only a single package is mentioned, but if we want to specify multiple packages, we can provide a list of those packages in the curly braces as well. Next option is basePackageClasses. This option specifies the base classes to use as a reference for package scanning. Spring will use the package of the specified classes to search for the components. For example, we have myController.class and myService.class in this example. So what Spring will do, it will check these classes and what is their package, and those specific packages then will be scanned for all other components which Spring can manage. Next option is includeFilters. So in case we want to add specific classes or interface and not the whole package, then we can use this particular option. For example, you can handle all classes annotated with @controller or @service or classes that implement a specific interface. In this example, we are using includeFilters to include all the classes annotated with @controller in com.example package. So in this example, we can see in the include filter option, we are providing the details like we need to consider all the classes with the annotation @controller to be considered for scanning and managing their beans as well. Using include filters can be helpful when you want to limit the scope of component scanning to specific subset of classes or interfaces and avoid registering the unwanted or unnecessary components in the Spring container. Next is exclude filter. Many times we have specific requirement not to instantiate some beans automatically. So in that case, we need to remove them from getting automatically configured. For that, we can use exclude filters. It allows you to exclude specific classes or interfaces when scanning for the component to register. When using exclude filter, you can specify one or more classes or interfaces that should be excluded during the scanning process. For example, you can exclude all classes annotated with @controller or @service or classes that implement a specific interface. In this example, we are using exclude filter to exclude all the classes which are annotated with @controller in the com.example package. It can also be useful when you need to exclude certain components that might conflict with other components or cause issue in your application. The last property that we will be discussing is use default filters. This option allows you to enable or disable the default filters that are applied during component scanning. By default, Spring will scan all the classes in specified package and register any class that is annotated with the annotations we have discussed earlier, like component, service, repository, controller, REST controller, etc. This behavior can be modified by specifying custom filters or disabling the default filters. When use default filter option is set to true, which is by default also, the default filters are applied during the component scanning. But when it is set to false, the default filters are not applied and only the custom filters that is specified, those will be applied. So in this example, we are disabling the default filters by setting the use default value to false and instead using a custom filter to include only classes which are annotated with my custom annotation. So here you can see we have added an option of use default filter and set its value to false, and after that we have provided our own filter because the default filter will not work now. So based on our own filter which we have provided here, like we want to use all the classes which are annotated with my custom annotation, only those will be considered for scanning and creating the beans for them. All these options gives you a lot of flexibility and control over the component scanning process, allowing you to fine tune the way Spring discover and manage the components in your application. That's it for this video. We will cover some more concepts of Spring Framework in the next video. Please let me know if you want me to cover some specific topics on Spring. I hope this video was helpful to you. In case you like it, please share it across with your dev community. Also, don't forget to like and comment with your feedback. Thank you so much for watching. Keep learning.